we are going to learn about the Pythagorean Theorem. But before we review that, let's go over some terminology. The Pythagorean Theorem can only work with right triangles. The theorem cannot work with acute or obtuse triangles. There needs to be a 90-degree angle in the triangle in order for us to use the Pythagorean Theorem. And there are three sides in a triangle. The two sides that are touching the right angle are called the legs. The side that is opposite the right angle is called the hypotenuse. So if I have this right triangle, this is a leg since it is touching the right angle, and this is also a leg because it is touching the right angle. This is the hypotenuse since it is opposite the right angle. If I have this right triangle, this is the leg since it is touching the right angle, and this is also a leg. This is the hypotenuse since it is opposite the right angle. If I have this right triangle, this is the leg, and this is also the leg since they are touching or are right next to the right angle. This is the hypotenuse since this side is opposite the right angle. If I have this right triangle, this is the leg and this is also the leg, since they are the sides touching the right angle. And this is the hypotenuse, since it is opposite the right angle. If it helps, you can first look at the side that is opposite the right angle, and that is the hypotenuse, and therefore the other two sides are the legs. So if I have a right triangle over here, the two legs, which are the sides of the triangle that touch the right angle, I'm going to label these A and B. The side opposite the right angle, which is called the hypotenuse, will be labeled C. The Pythagorean theorem says C squared equals A squared plus B squared. This essentially says that the square of the hypotenuse equals the sum of the squares of the two legs. If you're confused with all the variables involved in this theorem, let's do some practice problems. Let's say I have a triangle with legs of 5 and 12. What is the hypotenuse? Remember, the hypotenuse is C, so we are going to use the formula to solve for C. The Pythagorean theorem says C squared equals A squared plus B squared, where C is the hypotenuse and A and B are the legs. Therefore, I will set the equation as C squared equals 5 squared plus 12 squared, since 5 and 12 are the legs of the triangle. It doesn't matter if A equals 5 or if B equals 5. In the end, you're just squaring and adding the two legs together, so it doesn't matter if 5 or 12 are A or B. I could set up the problem as C squared equals 5 squared plus 12 squared, where 5 is A and 12 is B, or I can set the equation as C squared equals 12 squared plus 5 squared, where 12 is A and 5 is B. Either way, both these equations are going to get you to the same answer. So let's use C squared equals 5 squared plus 12 squared. 5 squared is 25 and 12 squared is 144. Therefore, you will get C squared equals 25 plus 144. 25 plus 144 is 169. So you will get C squared equals 169. Then, you take the square root of both sides, and you will get C equals plus or minus 13. Now let's think about this for a second. You can't have a negative side. This side C does not look like a negative number and cannot be a negative number. Therefore, C equals positive 13. The hypotenuse is 13. Let's try another problem. If we have a right triangle here, with the legs being 8 and 7, what is the third side of the triangle? Since the problem gave you the two legs, you know that you are solving for the hypotenuse, which is the side opposite the right angle. So we have the formula c squared equals a squared plus b squared. The legs are 8 and 10, so we will substitute the numbers in this formula for a and b. We will get c squared equals 8 squared plus 7 squared. 8 squared equals 64 and 7 squared equals 49. We have c squared equals 113. When we square root both sides to solve for c, we will get c equals the square root of 113. Therefore, the third side of the triangle, hence the hypotenuse in this case, is the square root of 113. Let's try another problem. What is the third side of an acute triangle with the legs 4 and 5? Now let's look at this problem very closely. In order for us to use the Pythagorean theorem, the triangle has to be a right triangle. The problem said that it was an acute triangle. Therefore, we cannot use the Pythagorean theorem in this problem and do not know the answer to the problem. We cannot do this problem since it is an acute triangle and not a right triangle. Let's try another problem. If we have a right triangle with the leg of 3 and the hypotenuse being 5, what is the third side? In this problem, we are given a leg and a hypotenuse. Keep in mind that all right triangles have 2 legs and 1 hypotenuse. Since we are given a leg and the hypotenuse, we are solving for the other leg. We are solving for a side of the triangle that touches the right angle. So let's draw a picture. This is a right triangle. And 3 is a leg, so 3 will be here. And 5 is the hypotenuse, so 5 will be opposite the right angle. The Pythagorean theorem says c squared equals a squared plus b squared. Since c is the hypotenuse, we will substitute 5 for c. Then we will substitute 3 for a since it is the leg. We will get 5 squared equals 3 squared plus b squared. 5 squared equals 25 and 3 squared equals 9. We will get 25 equals 9 plus b squared. When we subtract by 9 on both sides, we will get 16 equals b squared. When we square root both sides, we will get 4 equals b. Hence, b equals 4. Therefore, the third side, or in this case, the other leg of the triangle, equals 4. When doing these problems, you have to keep in mind what the legs and what the hypotenuse is. If you accidentally substituted 5 in b instead of c, you would get a different answer since you substituted incorrectly. Make sure to read the problem carefully to see what the legs of the triangle are and what the hypotenuse of the triangle is. Let's try another problem. What is the third side of a right triangle with the leg of 5 and a hypotenuse of 8? In this problem, we are given a leg and a hypotenuse. Keep in mind that all right triangles have 2 legs and 1 hypotenuse. Since we are given a leg and the hypotenuse, we are solving for the other leg. And if a problem doesn't give you a picture, let's draw a picture. So we have a right triangle, and this is the right angle. We have a leg that is equal to 5, and the legs always touch the right angle, so this is the leg. The hypotenuse is always opposite the right angle, so the hypotenuse, which in this case is 8, is right here. And this is the side we want to solve for. Now that we have our picture, let's do the calculations. The Pythagorean theorem says c squared equals a squared plus b squared. Since c is the hypotenuse, we will substitute 8 for c. Then, we will substitute 5 for a since it is the leg. We will get 8 squared equals 5 squared plus b squared. We will get 64 equals 25 plus b squared. When we subtract 25 on both sides to isolate b, we get 39 equals b squared. When we square root both sides, we will get the square root of 39 equals b. Hence, b equals the square root of 39. Therefore, the third side, or in this case, the other leg of the triangle, equals the square root of 39. Now let's try a more interesting problem. What is the third side of a triangle with the hypotenuse of 3 and the leg of 6? In this problem, we are given a leg and hypotenuse. In a right triangle, there are 2 legs and 1 hypotenuse. Since we are given a leg and the hypotenuse in this problem, we are solving for the other leg. And I'm not going to draw a picture for this one just yet for a particular reason I'm going to show. The Pythagorean Theorem says c squared equals a squared plus b squared. In the problem it says the hypotenuse is 3, so we will substitute 3 for c. In the problem it also says 6 is a leg, so we will substitute 6 for a. We will then get 3 squared equals 6 squared plus b squared. 3 squared equals 9, and 6 squared equals 36. We will then get 9 equals 36 plus b squared. We want to isolate and solve for b, so we will subtract by 36 on both sides. We will get negative 27 equals b squared. Since we want to solve for b, we have to take the square root of both sides. But this is interesting. How do you take the square root of negative 27? What's the square root of a negative number? You might be thinking that you can use I, but I is an imaginary number. It wouldn't work for a triangle. And this is one reason why it is so important to draw a picture. So let's draw a picture for this. And I'm going to try to draw the picture to scale. So we have a leg which is 6, and the right angle is right here. And the hypotenuse is always opposite the right angle. So the hypotenuse, which is 3, is going to be right here. What you'll notice is that this line cannot connect, so that this is a right triangle. If it were a right triangle, it would connect like this. But it's not. And the reason why is because the hypotenuse is shorter than the leg. The hypotenuse in this problem is 3, and the leg in this problem is 6. The hypotenuse is shorter than the leg. One important thing to know about right triangles is that the hypotenuse is the longest side of the triangle. If the hypotenuse is shorter than any of the triangle's legs, then it is not a right triangle. In this case, it seems like a slightly obtuse triangle, and we cannot do anything with it. It's an obtuse triangle, so we can't solve for the third side. We can't use the Pythagorean theorem. And if you look at the problem, what is the third side of a triangle with a hypotenuse of 3 and a leg of 6? It never specified that it was a right triangle. There may be some occasionally trick problems like these, but they are not the main problems teachers ask. In the end, make sure to read the question carefully to determine what the legs and hypotenuse are, whether it is a right triangle or not, and make sure to draw a picture.